Hello students, are you ready to learn something new? So let's start. Now we will learn how to draw the graph of sine x. Now at first make a table for the values of x and y. So if x is 0, then sine 0 is 0, it means y is also 0. If x is 30, then sine 30 is 1 by 2, that is 0.5. If x is 60, then sine 60 is root 3 by 2, that is 0.866. We can write it as 0.9. And sine 90 is 1. Then 120, sine 120 is 0.9. Then 150 is, sine 150 is 0.5. Sine 180 is 0. And sine 210 is minus 0.5, sine 240 is minus 0.9, and 270 is minus 1. We can easily find out these values. Then 300 is minus 0.9, 330 is minus 0.5, and 360 is again 0. We can take some negative values. Now, if x is minus 30, then sine of minus 30 is minus sine 30. It means minus 1 by 2. It means minus 0.5. And if we are taking minus 60, then it is minus 0.9, and minus 90 is again minus 1. Now we will draw the graph. Now this is x-axis, y-axis, x dash, negative x, and here we have negative y, that is y dash. This is origin. Now 30, 60, 90, 120, 150, 180, 240, 270, it's 300, 330, and 360. Draw these graphs on graph paper so that these intervals can be equal. Minus 60, minus 90, and so on. Now, here it is 0.1, 0.2, 0.3, 0.4, 0.5, 0.7, 0.8, 0.9, and here it is 1.0. Same, minus 0.1, minus 0.2, minus 0.4, minus 0.6, minus 0.7, minus 0.8, minus 0.9, and at last here it is 1, minus 1. Now 0, if x is 0, then y is 0. If x is 30, y is 0.5. Somewhere here 60 is 0.9. Then sine 90 is 1. Now 120 is 0.9. 150 is 0.5. Then 180 is 0. Now we can join them. Join these points by freehand. Now 210 is minus 0.5. 240 is minus 0.9. 270 is minus 1. 300 is again minus 0.5. 330 is minus 300 is minus 0.9 and 330 is minus 0.5. Then 360 is again 0. Then we can join them like this. Now minus 30 is minus 0.5. Minus 60 is minus 0.9. Minus 90 is minus 1. We can also join them and it will come like this, and it will meet x-axis at 180. So in this way we can draw the graph of sin x. Now we will draw the graph of phi is equal to tangent x. So at first make a table for the values of x and y. If x is 0, then y is 0. If x is 45, then y is 1. If x is 90, then y is infinity, or we can say not defined. Then if we have tangent 135, then it is minus 1. If we have tangent 180, that is 0. If we have 225, then tangent 225 is 1. Then if we have tangent 270, it is infinity, not defined. Then if we have tangent 360, then it is 0. We can also take negative values. If x is minus 45, then it is minus 1. Then minus 90, minus infinity, not defined. Then minus 135, that is plus 1. Now we will draw the graph of tangent x. Now, if we have x is equal to 0, then y is also 0. When x is 45, then y is 1. If x is 90, then y is infinity. It means not defined. It means we don't have any point. So we can represent it by dotted line. Now, so we can draw it like this. Now, 135 is minus 1. Somewhere here, this minus 1. Now, 180 is 0. Now, 225 is 1. Now, 270 is again minus infinity. So, at point 270, we will draw a dotted line and we can plot it as now we have 315, that is minus 1. Now at 360 it's 0. Again it will come like this and so on. Now here minus 45 is minus 1. Then minus 90 is again minus infinity. So we can plot a dotted line and we can continue like this. So in this way we can draw the graph of If we don't have any point, then we can leave it S. So in this way, we can draw the graph of tangent x. Now we will draw the graph of cosecant x. Now if x is 0, then y is not defined. If x is pi by 4, then y is root 2. It means 1.414. Now if x is 90 pi by 2, then y is 1. If we have x is equal to 3 pi by 4, then y is root 2. It means 1.414. Then pi is not defined. So we can draw it like this. We will get the shape like this. Proper U shape we will get. Now, if we have 5 pi by 4, then it is minus root 2. It means minus 1.414. Then 3 pi by 2 is minus 1. Then 7 pi by 4 is again minus 1.4. And 2 pi is again not defined. So we will get shape like this. Now, minus pi by 4, that is minus root 2. It means minus 1.414. Then minus pi by 2 is minus 1. Then minus pi is infinity, means not defined. And if we take one more value, that is minus 3 pi by 4, again we will get minus 1.14. So we can represent it here. And again we will get shape like this. Now what is domain and range of sine function? Y is defined for all real x. Therefore, domain of sine x is all real numbers. And for all x, y lies between minus 1 to 1. So, range of this function is minus 1 to 1, or we can say range is close interval minus 1 to 1. It means y lies between minus 1 to 1, including minus 1 and 1. Similarly, we can draw the graph of cos x, and domain of cos function is also real numbers, because if we have y is equal to cos x, then y is defined for all real x. And similarly, value of y will lie between minus 1 and 1, including minus 1 and 1. So range becomes close interval minus 1 to 1. Now what's about period of sine x? Values of sine x repeats after an interval of 2 pi. We can see values of sine x repeats after an interval of 2 pi. Therefore, period of sine x is 2 pi. Similarly, period of cos x is also 2 pi. Now, what is the domain of tangent x? Domain is if we have y is equal to tangent x, it means sin x by cos x. Y is defined only when this cos x is not equal to 0. It means x should not be equal to 2n plus 1 into pi by 2, where n belongs to integer. So what is domain? We can write it as x belongs to R, but x is not equal to 2n plus 1 into pi by 2, where n belongs to integer. Or we can say domain is R minus 2n plus 1 into pi by 2, where n belongs to integer. And for all x, y is also again a real number. So range of tangent function is all real numbers. So domain is real number except numbers of 2n plus 1 into pi by 2, where n belongs to integer, and range is all real numbers. Now y is equal to cot x, it means cos x by sin x. Now y is defined only when sin x is not equal to 0. It means x should not be equal to n pi, where n belongs to integer. So domain of cot function is, domain means x belongs to R, and x is not equal to n pi, where n belongs to integer. Now, what is the range of cot x? Values of cot function lies between minus infinity to infinity. It means all real numbers. So range of cot function is all real numbers. Now, what's about period of tangent x and cot x? Values of tangent x again repeat after an interval of pi. Same in cot x. So, period of tangent x and cot x is pi. Now, what is the domain of secant x? We can write it as 1 upon cos x. Now, y is defined only when cos x is not equal to 0. It means x is not equal to 2n plus 1 into pi by 2. So what is domain of secant function? Domain means value of x. X belongs to R, but x is not equal to 2n plus 1 into pi by 2, where n belongs to integer. Now, what is the range of function? Now, value of y of secant function lies from 1 to infinity and minus 1 to infinity. As we can see in the graph, there is no value between minus 1 to 1. So range means value of y. So y, it means range is minus infinity to minus 1 union 1 to infinity. It means value of y lies in the range of minus 1 to minus infinity and 1 to infinity. So range of function is minus infinity to minus 1 union 1 to infinity. Now, what is the period of secant x? Values of secant x repeats after an interval of 2 pi. It means period of function is 2 pi. So period of secant x is 2 pi. Now what is the domain of cosecant x? We can write it as 1 upon sin x. So y is defined only when sin x is not equal to 0. It means x is not equal to n pi. So what is domain of sin x? We can write it as x. X belongs to R, but x is not equal to n pi, where n belongs to integer. And from graph, we can see the value of y lies, this is 0, this is 1. From 1 to infinity and minus 1 to infinity. There is no value between minus 1 to 1. So range of function is minus infinity to minus 1 union 1 to infinity. It means minus 1 is included and all the values less than minus 1. Again, 1 is included and all the values greater than 1 are in the range of cosecant x. But there is no value between minus 1 and 1. Now, what is period of cosecant x? Again, values of cosecant x again repeat after an interval of 2 pi. So, period of cosecant x is also 2 pi. Now we will do the proof of the result theta is equal to L by R. Consider a circle with center O and radius is R. Let length of arc AB is L units and this angle is theta radians. Now we have to prove that theta is equal to L by R. For this, we will take another arc, that is AC, which is equal to the radius of the circle. So, OC is the radius of circle, therefore R units, and CA is also R units. Therefore, by the definition of 1 radian, this angle should be 1 radian. Because if length of arc is equal to the radius of the circle, then the angle subtended by this arc at the center of circle is always 1 radian. Now we know that measure of central angles of the arc of a circle are proportional to the length of their arcs. It means if we have this angle theta radians upon 1 radian, this ratio is equal to the ratio of their length of arcs. Now it means L units upon R units, and units of both L and R should be same. So in this way we can say that theta is equal to L by R. Now we will do some questions based on the formula theta is equal to L by R. And the first question is, in a circle of diameter 40 centimeter, the length of a chord is 20 centimeter. So diameter of circle is 40 centimeter. Therefore, radius of circle is 20 centimeter. Now, if we have a circle with center O and length of chord is 20 centimeter, radius of the circle is 20 centimeter, therefore OA and OB both are equal to 20 centimeters. Now, in triangle OAB, all the sides are equal. Therefore, triangle OAB is an equilateral triangle. Therefore, this angle is 60 degrees. Or we can say pi by 3 radians. And we have to find the length of minor arc of the chord. This AB is the minor arc. So we have to find this length. We can represent it by L units, or we can say centimeter, because unit should be same. And radius is 20 centimeter. And this theta, this angle is pi by 3 radians. So we have figure like this. This is O, this is A, this is B, this is pi by 3, and this is L centimeter, this is 20 centimeter. So we can apply the formula of theta is equal to L by R. Now put all the values. What is theta? Theta is pi by 3 radians. What is L? L is L centimeter. What's about radius? That is 20 centimeter. Or simply we can write 20. And unit of length of arc and radius should be same. So L is 20 pi by 3 centimeter. Now next statement is, if in two circles arc of the same length subtend angle 60 degrees and 75 degrees at the center, then find the ratio of their radii. We have two circles. We have two arcs AB and CD. Both are of equal length. So let length of arc AB is L units. Same, CD is also L units. Now, this is the center of the circle. O dash is the center of this circle. Now, these are subtend angle 60 degrees at the center and 75 degrees. Now we have to find the ratio of their radii. Let radius of this circle is small r units and radius of this circle is capital R units. Now we know that theta is equal to L by R. So we can write it as 60 degrees is equal to L by R. But in this formula, theta should be in radians. So we can write it as pi by 3. So pi by 3 is equal to L by R. Same in this circle, theta is equal to L by capital R. Again, theta should be in radians. So we can convert 75 degrees into radians by multiplying pi by 180. We can write it as pi by 12. 5 pi by 12. So we can write it as 5 pi by 12. Now we have to find the ratio of their radii. So here small r is equal to 3l upon pi and capital R is 12l upon 5 pi. Now what is r upon capital R? 3l upon 12l. We can cancel it. So ratio of radii is 1:4. And the last question is, a wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? So number of revolutions in 1 minute or 60 seconds is equal to 360 revolutions. Now number of revolution in 1 second will be 360 upon 60. It means 6 revolution. Now 1 revolution means complete angle, and 1 complete angle is equal to 360 degrees, or we can say 2 pi radians. Means 1 revolution is equal to 2 pi radians. But we have 6 revolutions, therefore 6 revolutions is equal to 6 into 2 pi, that is 12 pi radians. That's all for today. Thank you all.